Okay, so section 2.3 is modeling when is a numerically given function linear. So this worksheet, a lot of the times you're just going to be figuring out when, based on a table, if a function is linear, and then we'll go ahead and find, if it is linear, we'll find the, we'll write it as a linear function and we'll write it out. So for problem 1, we're going to do A, B, and C together. I'll leave D and E for you guys. So looking at A, we have to determine if the table can represent a linear function and explain your reasoning. For each table that could represent a linear function, find the formula for that function. Okay. This first one, table A, we see from 0, well, in order to tell if a function's linear based off of a table, we want to make sure that the x and y value is incrementing at a constant rate. So from 0 to 1, we're adding 1. From 1 to 2, we're adding 1. And from 2 to 3, we're adding 1. The only we have to make sure that the x values are incrementing at a constant rate, because we want to make sure that we're comparing evenly spaced values. Because if you think about like a graph, you're going to have all x values. So really any x values can be put in a table, but we want to go ahead and make sure that that we're comparing points that are evenly spaced along the x-axis. Okay, and then for the y values in table A, we have 12.6 and 9.3. If you subtract both those, we're going down, so minus 3.3. And then from 9.3 to 0.6 or 6.0, we're going down 3.3. And then from 6 to 2.7, we're going down 3.3. So this is a linear function. So yes, it's a linear function. And it's a linear function because our x and y values are increasing or decreasing at a constant rate. So that means that our slope, remember, it's the change in y over change in x. So our change in y change in x is, our change in y is negative 3.3, and our change in x is 1. So it's negative 3.3 is our slope. We do know the y-intercept, so you could do it either way. We might not always know the y-intercept, so we know that this point here is the y-intercept. Or the vertical intercept, whatever way you want to say it. So you can either do y equals mx plus b. So, well, we'll do mx plus b, which is equal to negative 3.3 x plus 12.6. If you're not given, or the next example we'll do it, the way this question is written, it doesn't matter. It just says find the formula for that function. I wrote functions, but for that function. It doesn't matter what form you write it in, just have an equation that represents it. So you can do y equals mx plus b, so slope intercept form, or you could do point slope form, whatever way you prefer. So for table, so this is your answer for the first one. For table B, let's check what our t is incrementing by. So we go from negative 1 to 1, so that's plus 2. We go from 1 to 3, that's plus 2. we go from 3 to 5, and that's plus 2. And then when we go ahead and check our y-intercept, our f of t values, our y values, we have from 0.1 to 0.4, that's plus 0.3. From 0.4 to 0.7, that's plus 0.3. And then 0.7 to 0.1, that's plus 0.3. So yes, it's linear. Our slope, again, change in y over change in x. So our slope is our change in y, which is 0.3 over our change in x, which is 2. And if you divide that out, it's 0.15. Yep. Okay. So now we don't have our vertical intercept in the table, but what we do have is we have plenty of points. So we could choose any point. I'm just going to go ahead and choose, I don't know, let's choose this point. So we have y minus y1 equals m times x minus x1. So we have y equals m, which is 0.15 times, oops, well, yeah. Sorry. I could move this y1 to the other side. So we have y equals m times x minus x1 plus y. So now I can write it just plugging in my slope in my point over here. We have 0.15 times x minus x1, which is 1, plus 0.4. And that would be your solution. Any questions there?
That's the final answer?
Yep, so your final answer is this equation here, which I'm showing you more work than you guys need to do because I'm walking you through it. You don't need to explicitly find the slope. If you could look at this and do all that, like plug in your slope and whatever, find it easily. As long you don't even need to write out the form that you're writing in. You just would need to write, like for your solutions, if you want, you could have show as much work as you want, but all you need is this part in y, or this, like y equals that. And really, actually, we should be doing, this should be f of t, and this value here should be t. So keep track of the variables that are given to you, which I did a bad job on that one of doing, but yeah.
I have a question.
Mm-hmm.
In the directions, it says like explain your reasoning. So are we supposed to write like a sentence if it is a slope or not?
So no, so if it is a linear function, you don't have to explain your reasoning. But if it's not, I'd want to see the reason why.
Okay, thank you.
Mm-hmm. All right, so then this last one that we're going to do together is C. Okay, 0 to 1.5 is obviously plus 1.5. 1.5 to 3 is plus 1.5. 3 to 4.5 is plus 1.5, and then 4.5 to 6 is plus 1.5. Okay, those are incrementing, so we can continue. Or those are incrementing at a constant rate. 12 to 18 is plus 6. But then we go from 18 to 12, and that's minus 6. So we can stop here, and we could say, no, this is not a linear function because g of n is not increasing or slash decreasing at a constant rate. Okay, so you guys will be doing D and E together, but do you have any questions? I meant D and E on your own, not together. Okay. All right, we'll go ahead and move on to the next page. What ones are we? Problem 2 you're going to do on your own. Problem 3 we'll do together. So the height of a human individual can be estimated by the length of the femur, as shown for males in the following table. I wish I should have written this as lowercase l. Usually inputs are lowercase, so L is the length of the femur in centimeters. H is the height of the femur L is the length of the femur in centimeters. H is the height of the male in centimeters. Use this information in the table to find a possible formula for the height of the human male, H, as a function of his femur length, L. Okay, so we're already told right off the bat that it's a linear function, so we don't have to check it. We will have to find our slope, so we just have to choose 2 points and kind of find the difference between them. Uh-oh. My AirPod just fell. I have no idea where it went. Oh, can you guys still hear me?
Yes.
Okay, cool. Go on with 1 until I find it. All right. So use this information in the table to find a possible formula for the height of the human male H as a function of the femur length L. So from 42 to 45 for the length of the femur, we're increasing by 3 centimeters. And then from 162.97 to 169.93, we're increasing by 6.96. No, that's right. Yes, 6.96. So plus 6.96. So use the information in this table to find the possible. Okay. So first we have to find the slope. Slope again, change in y over change in x. So we have 6.96 divided by 3, which is 2.32. Okay. Again, it doesn't specify what form the linear formula needs to, the formula for the linear function needs to be in. So we have h of l equals, I'm going to do point slope form where it's y equals m times, it'll be L minus L1, and then plus H1. Oops. H of t. So I'm going to use that form. So my slope we just found out was 2.32 times L minus L1. I'm going to pick any point. So we'll pick this one, minus 48 plus 176.89. And that's your solution. Any questions there? Okay, so for part B, what would the approximate height of a human male with femur length 46 centimeters be? Can someone tell me how we should go about this problem now that we have the formula for the linear function?
Plug in 46.
Yes, good. So we're going to do now h of 46, which is equal to 2.32 times 46 minus 48 plus 176.89. Okay, so plug that into your calculators. Don't forget order of operations. 2.32 times 46 minus 48 plus 176.89 is 182.25 centimeters. Any questions there? All right, cool. So then for part C, Fernando is 175.4 centimeters tall. What would you expect the approximate length of his femur to be? Can someone explain to me how we set this one up?
Wouldn't you have to solve for L?
Yes, so we're going to solve for L. So we're going to set h of L equal to 175.4. So we have 175.4 is equal to 2.32 times L minus 48 plus 176.89. Okay. First thing we could do is distribute this 2.32 to the parentheses. So we have 175.4 is equal to 2.32 L minus 48 times 2.32 is 111.36 plus 176.89. I'm going to go ahead and combine my like terms right here. So we have 111.36 plus 176.89 is 175.4 equals 2.32 L plus negative 111.36 plus 65.53. Now subtract this to the other side. So 175.4 minus 65.53 is 109.87 is equal to 2.32 L. So now divide both sides by 2.32. And you get 40. So L equals 47.36 centimeters. So Fernando is 47.3, or his femur. Fernando's femur is 47.36 centimeters long. Okay. Any questions on that one? All right. We're going to do problem 4 together, and then I'll leave the other one 5 for you. Yeah. Okay. A hiker is at a trailhead about to climb a mountain. The temperature at the trailhead is 65 degrees Fahrenheit. According to the standard atmosphere model, the temperature drops by 0.00356 degrees Fahrenheit per each 1 foot increase in altitude. Let T equals T of H be the temperature in degrees Fahrenheit and H height above or feet above the hiker. Write a formula for the function T of H. All right, so this one's tricky because it doesn't seem like we're given much information, but if we kind of think about it, we get all the information that we need. So I think the easiest thing to pull out of this word problem is the slope. We're told that the temperature drops by this value per each 1 foot increase in altitude. Anytime you see anything that looks like any sort of rate, it's probably your slope. So this is our slope. So we know that our slope is 0.00356. Now, it doesn't seem like we're given any other information. The only other information that we're given is the temperature at the trailhead is 65 degrees Fahrenheit. And since we're measuring the H feet above the hiker, and the trailhead is probably at the bottom of the hiker, I'll go back to 3 when we start doing independent work. The trailhead is at the start of the hike, and it's where the hiker initially is. So this value here actually tells us that we have our what one is it? The H is 0, so we have our vertical intercept. So 65 degrees Fahrenheit. This is our vertical intercept, so we have the point 0, 65. Okay. So now it's T of H. T of H is equal to, we could do y equals mx plus b form. So 0.00356 times h plus 65. Any questions there? Okay.
Would the slope be negative because it's dropped?
Oh, yes. Yep.
Okay, I wasn't sure.
It's negative 0. Yep. So it's negative because the temperature is dropping. Okay. Question B, find the temperature at the mountaintop that is 6,210 feet above the hiker. So this means that we're going to go ahead and plug 6,210 feet in for our function for H. So T of 6,210 is equal to negative 0.00356 times 6,210 plus 65 is equal to 42.644 degrees Fahrenheit. And lastly, is the function increasing or decreasing? Since the slope is negative, so as the hiker climbs higher, so as H increases, then the temperature is decreasing. So the slope is negative. So the function is is decreasing. Any questions? All right, so go ahead and start working on the other problems. I will go back to 3 once you guys are done copying 4. So let me know once you guys are done copying 4, please. At some point for number 3, I somehow added 10 to it. So I don't know how, but oops, this should be 172.25 centimeters. All right. Is that what you